on the update on the latest audio testing technology. So before we start, allow me to just briefly introduce our company profile. So we are from TME Systems. So our company started in 1987. So next year is our 40th anniversary. And our business coverage mainly we are active in the Southeast Asia market, including Singapore, Thailand, Malaysia. So for today's agenda is, first of all, I'm Theo, the person who is doing the welcome and also the MC for this session. And the first topic that we would like to cover will be introduction to the PSIO. And this will be presented by my colleague Jeff from Singapore side. And then following that will be introduction to the Bluetooth 5 LE audio by our colleague from Thailand, Sean. And following that will be followed by a brief demonstration on Bluetooth 5 by our colleague Gary from our technical support team. And then lastly, the last session will be followed by introduction to the latest APx500 software. And this will be presented by our colleague from Malaysia, and this Eric. And then lastly, will be the Q&A session. So if you have any question after that, please feel free to type in your question in the chat box, and we will try our best to answer all the questions. So just a brief introduction to the history of Audio Precision. So it is a US company, and it has more than 35 years of history. And since then, they have been widely recognized as the leader in the audio testing field. And they started in 1984, and till today, 2026, they have already achieved many milestones in creating first in the technology development in the area of audio testing. And a little bit about TME. So me and my colleague who are presenting today, we belong to the test management group. We have other colleagues that belong to other divisions that's dealing with the defense business and also the renewable energy, for example. Yeah. So for test management, we are mainly focusing in the area of acoustic and vibration related to automotive, aerospace, research and development, maybe electronic industry, testing, environmental. So basically, we covered various fields related to noise and vibration. And this slide shows some examples of sensors that we use for various industry. For example, like the flat microphone is used for testing noise in the outdoor, whereby there's a disturbance from the wind condition. And then next, we are dealing with also NVH, noise and vibration harshness testing. So this is one example, which is a sound intensity measurement, whereby we use two microphones to do a noise mapping. So with two microphones in opposite direction, it provides some directional information rather than just one microphone. There is no directional information. So we are also into vibration control and analysis. So we deal with shaker control system and also to measure and analyze, for example, in the area of model analysis. Then we also deal with a special technique of noise measurement, which is measuring the air vibration, and it's mainly used in near field acoustic, and whereby you can use it in a noisy area to map out the noise distribution from the test object and to find out from the color map which area has the highest noise leakage with respect to certain frequency. Then we are also into condition monitoring, including not only vibration, but also other parameters such as temperature, electrical current, voltage, speed, for example, thermography, PD, EMI. PD stands for partial discharge, dealing with arcing, like for example, coil equipment like transformers. Then roughly this is our after-sales service. We have our own workshop and CAL lab to provide after-sales calibration and repair service in our office. Then just a little bit about the past project we've done. Some example, such as this one shows some pictures of the system that we have set up for end-of-line testing, for audio testing of a car infotainment system. This project is actually for one of the Japanese car makers in Thailand. And then the next example, just to share with you, we also did one proof of concept in Thailand to test the real condition of a train by using acceleration from vibration and to look at the pattern to differentiate between a good and bad wheel from a train. So thank you. This is my brief introduction to me. So next, I will hand over to the first speaker of this session, and his name is Jeff. So he will talk about PSIO. Jeff, over to you.
Hello, good afternoon, everyone. My name is Jeff Leong. I'm the product manager for audio precision and glass product at TME Systems. I'm currently based in Singapore and supporting customers across Singapore and the Philippines area. Today, I would like to introduce Audio Precision's newly launched digital audio interface module, the Programmable Serial I/O, or I call it as PSIO. Let's first look at the Audio Precision current digital interface module, which is the Digital Serial I/O, or we known as DSIO. I believe many of you already have a DSIO module installed in your APx analyzer, and some of you are very familiar with its capabilities. DSIO has been one of the Audio Precision most successful digital audio modules. However, as digital audio devices continue to evolve, engineers require greater flexibility, higher performance, and support for more complex digital interfaces. As a result, PSIO will replace DSIO in all the new analyzer purchased in going forward. Let's take a look on the design of the hardware of DSIO and PSIO. This chart compares Audio Precision PSIO module with the older DSIO module used for testing digital audio interfaces, such as I2S, TDM, DSP audio links, codec, Bluetooth audio chipset, and SoC. PSIO is the newer, more flexible, and more powerful platform. It was designed to support modern audio IC and embedded systems, while DSIO was optimized for traditional I2S testing. PSIO offers lower logic voltage level from 1.8 volt to 0.5 volt. This is important when testing modern low-power chips. PSIO can interface directly without level shifters in many cases. PSIO offers higher sampling rate from 432 kHz to 638 kHz. The higher sampling rates allow testing high-resolution audio. Professional studio equipment, modern DAC and ADC. PSIO is more channel flexibility compared to DSIO. It supports up to 16 channels, and DSIO supports only 1, 2, 4, 8, and 16 channels. PSIO also offers pairing support and allows DUT to provide clock to AP analyzer, and AP analyzers provide clock to DUT independently. This is extremely useful for master-slave verification, clock synchronization testing, Bluetooth audio chip validation, and codec testing. The distance between the digital module and the DUT increased from 50 centimeter to 10 meter. This is one of the biggest practical improvements, which allowed the DUT to be tested in the anechoic chamber and the PSIO remain outside the chamber. PSIO offers 4 dedicated BNC output, which signals can be monitored directly on oscilloscope and logic analyzer under the control of APx500 software. In DSIO, it used Hydra cable or 8 BNC breakout cable with less integrated flexibility. This slide shows the actual configuration screen of the legacy DSIO module versus the newer PS module in the APx500 software version 9.3 and above. The red boxes highlight the additional flexibility and capability that PSIO brings to digital audio interface testing. This slide focuses on the physical hardware connection differences between the older DSIO and the newer PSIO interface. The DSIO connects directly from the APX analyzer to the DUT. Multiple cable runs from the APX analyzer to the DUT, and the DUT must be located very close to the APX analyzer. The typical cable length is about 50 cm. It may suffer signal integrity issue over longer distance. Where in PSIO, the POD, which is in the red box, acts as a remote digital interface module positioned near the DUT. The POD is essentially a remote interface hub that receives commands from APX analyzer. It generates clocks, send and receive digital audio streams, receive digital audio stream, and perform voltage level translation. Oops. All the new purchase will include the POD and a white cable with defined cable length. The length could be 2 meter, 5 meter, and 10 meter. For PSIO, a few cable type selections are available. The 2-pin breakout cables and a 4 BNC breakout cable. Next, I would like to share with you on a quick tip video of the PSIO.
This quick tip introduces the new Programmable Serial I/O module and the companion Programmable Serial I/O pod. The new PSIO module, along with a sleek and stylish PSIO pod, provides a general purpose and highly configurable interface for chip-level digital audio interfaces such as I2S, TDM, DSP, and other protocols. The PSIO module connects to the acoustically silent remote PSIO pod with a 2, 5, or 10 meter cable, so the pod can be placed away from the analyzer in locations like an anechoic chamber without causing audio interference while testing. The pod can also be conveniently placed right next to the device under test, eliminating the need for long cable runs. PSIO solution is highly configurable and, for both transmit and receive, supports up to 16 channels of data for one data line, or up to 16 channels total spread across up to 4 data lines. Master clock, bit clock, and frame or left-right clock signals are also available. Additionally, there are 4 BNC outputs in the back of the PSIO pod that can be used to monitor any of the clock or data lines with a logic analyzer or oscilloscope. PSIO module and PSIO pod combination is the most flexible and capable interface for developing and testing ADCs, DACs, DSPs, codecs, SOCs, and other audio integrated circuits. That's all for now.
Audio Precision is running some sales promotions on this newly launched PSIO module. AP offers 50% discount on software version upgrade or a 50% on software subscriptions model. It also offers up to 20% discount on the analyzer, the accessories, the options, and the extended warranty with the purchase of the new analyzer with PSIO module. To summarize, PSIO is the next evolution of audio precision's industry-leading digital audio interface technology. First, it built on the success of DSIO, which has been AP's most widely used digital audio module for many years. PSIO takes those proven capabilities and extends them even further. Second, PSIO addresses the needs of today's audio engineers by supporting lower logic voltage level down to 0.5 volts, higher sampling rates up to 768 kHz, and highly flexible frame and data formats for modern audio device and SoCs. Finally, PSIO introduces new innovations such as a remote operation through the POD, and enabling reliable testing inside NOK and RF chambers. It also provides software configurable monitoring outputs for easier debugging with logic analyzer and oscilloscope. In short, PSIO delivers greater flexibility, higher performance, and a more efficient workflow for next generation digital audio testing. Thank you, everyone.
Hi, thanks, Jeff. Thanks for the quick intro to the PSIO. So I hope it can give the audience a quick understanding of the latest PSIO technology. So next, we will hand over the session to the next speaker, Sean from Thailand, to speak a little about the Bluetooth. To you, Sean.
Okay, thank you, Theo. So, good afternoon, everyone. Allow me to introduce myself. My name is Sean. I'm currently based in Thailand, and I will be handling audio precision products in this region. So, if you have any requirements in this region, please feel free to contact me. Today, I will be presenting about audio precision Bluetooth 5 LE audio. This is the latest Bluetooth technology from Audio Precision. We will cover the topic on what is Bluetooth 5 LE audio and what is it capable of. And by the end of the presentation, we will show you the demonstration of how this module works. So what can Bluetooth 5 provide? As Bluetooth 5 is using the LC3 audio codecs, this results as much lower energy consumption while deliver higher quality compared to the classic Bluetooth. Bluetooth 5 also supports both Unicast, music, and voice. As you can see from the picture below, classic Bluetooth will connect through the daisy chain. This requires main and slave node, result as higher latency and unbalanced power consumption. Compared to the Bluetooth 5 LE audio, this is a direct audio stream to the DUT in parallel path, so the result as lower latency and balanced power consumption. And also, the Bluetooth 5 support the Auracast audio. This support one-to-many device transmission, enable many device connection scenarios such as gym venues that require to connect to many devices. Additionally, better interference resistance and lower latency. So this is the block diagram showing the connection between the streaming device and the DUT. The Unicast music will connect directly to the test unit and analyze in the audio analyzer. Same for the Auracast. The Auracast will be the broadcast device that connect to multi DUT one at a time. So you can analyze the signal from the test device. So about the Bluetooth 5, please take note that this is different from the Bluetooth Classic, as it have a different RF signaling scheme and data protocols. Newly purchased analyzer can support Bluetooth Classic and Bluetooth 5, but must be equipped in the same analyzer with two separate RF solutions. So about the Bluetooth 5 module, this is the next generation module supporting the latest Bluetooth version, compatible with all the B series AP analyzer. Can be installed in the new one or upgrade for the existing analyzer if you have one already. For the software part, it requires APx500 version 9.2 or above. Currently, our latest version is version 10. So target products such as headphone, earbuds, hearing aids, headset, and speaker manufacturing. So the analyzer can discover, scan, and pair with the other Bluetooth 5 devices. Can transmit unicast both music and voice. And for the unicast voice, it can receive from the DUT, like for example, headphone microphone. The analyzer can transmit Auracast and support the broadcast assist feature to direct the DUT to the audio stream without any phone app or middleman. Again, please take note that the release of the Bluetooth 5 does not support the classic audio such as A2DP or HFP. So if you still need to test these two, you will need the Bluetooth Duo module, but still can coexist with the Bluetooth 5 in the same analyzer. So in summary, for the Bluetooth 5 working at the master mode, in the Unicast Music 4.5, the data flow is unidirectional. So the transmit is support. For the Unicast voice profile, the data flow is bidirectional. It support both transmit and receive. And for the Auracast profile, the data flow is unidirectional, support on the transmit mode. We are also happy to announce that the Bluetooth 5 product has now been officially listed on the Bluetooth website. So if you go to the Bluetooth website and search for the audio precision, you will see the list of the product that's been officially listed on the website. You can find out more on the link below here if you wish to learn more. So this is all for the presentation. So now we move on to the demonstration part. Thank you.
Hi, thank you, Sean, for the brief introduction to this Bluetooth 5. Yeah, so next we will have our colleague from Singapore side, Gary from our technical support. He will present a brief demonstration to show you how to test the Bluetooth 5. Hi, Gary, over to you.
Hey, thank you, Mr. Teo. Hi, this is Gary from technical team. So let me run through for the Bluetooth 5 demonstration. Here I'm having the Bluetooth 5 set up to test on the Auracast and Unicast music. So let me brief through the device list that involved in this testing. So having the APx500 audio analyzer inbuilt with Bluetooth 5 module and the DUT, Samsung Buds 3 Pro, and it being supported for the testing by 40AG ear simulator, and the power conditioner to support the ear simulator is glass 12AA power modules. Okay, here firstly let me run through the Bluetooth 5 Auracast music by the APx500. At first, we set the output connector to the Bluetooth 5, scan and pair the Bluetooth device, identify the DUT, and then start to have the pairing process. The pairing process is done, and we set the mood to Unicast music, And we start to have the verification using 1 kHz sine tune. You can see from the FFT is showing the 1 kHz tune. And then next, we will add the measurement for the DUT delay. And click to start for the DUT delay test. And we capture the 194.8 millisecond. That is the advantage of the DUT on the delay repeatability. Next, we're going to add the frequency response. And we can just prolong the sweep time to have enough time for 1 second. Next, we click the start to run the testing. Here is the result, a capture from this testing, and we can adjust appropriate on the leveling to suit the different DUT under test. Here are some results by the different on the leveling. So showing the result on the different RMS value, relative level, and deviation. We are done here for the Unicast music. And next, let me show you for the Bluetooth 5 Auracast music set up by the APx500. First, we configure the Bluetooth 5 at the output output as the output generator, and start to have the pairing process. Identify the DUT and start to have the pairing. Once it's identified, it's connected. Next, we're going to configure the Bluetooth to Auracast mode and set the input to analog unbalance for the ear simulator. As to verify the connection, we are getting 1 kHz and the connection is perfect. Next, we're going to add the measurement for the DUT delay. Once we added the measurement, so we're going to use the pink noise and we start to have the stripping to check on the DUT delay. We are getting 203 milliseconds. Again, you're having a very good strength on the repeatability by Bluetooth 5 to maintain the same repeatability on 203 milliseconds. Next, we're going to add the frequency response to check on the Auracast music. Once we are done with the setup, we just click the start for the frequency response testing. And here are the result of measurements. You show the RMS, the gain, relative levels, and the deviation at last. Now we are done with the Auracast music. Next, I'm going to show you the demonstration on the Bluetooth 5 Unicast voice to check on the microphone performance of the DUT. Here, let me share again this setup for the device list, having the same APx516 audio analyzer with Bluetooth 5 module, the DUT Samsung Buds 3 Pro, and here I added a mini speaker as a sound source from the generator from the analyzer APx516, and as well as a holding jig for the testing on the microphone pickup. Let me run through the APX setup for the Unicast voice testing. Here, the other way around, we need to set the output as unbalanced to generate a sound source, and as an input as a Bluetooth 5, and we start to do a pairing process to enable the pairing to Bluetooth 5 to enable the microphones setup. Once we have paired, we set the connection mode to Unicast voice to check on the microphone. I selected the acoustic to check on the pickup by the microphone. As far as you can see, this microphone is picking up the environmental signal. And next, I'm going to add the measurement to check on the DUT delay. And start to have the DUT delay measurement. Click on the start, and we can see both channels having equally 192.7 and 0.8 millisecond. They are identical to each other to have an even equalization on the level. And next, I'm going to add the frequency response to check on the microphone pickup by both earpiece left and right channels. And here, I would like to reduce the frequency band stop frequency to 14K because I have been setting for 32 kilohertz for the sampling rate. To start the test, this is the result of measurement under open space, and this is the gain and the channel deviation, not more than 1.5 dB difference. I'm done with the demonstration. Thank you.
Okay, thank you, Gary. Thank you for the quick short demonstration on the Bluetooth 5. So next, we will have our last speaker. He's Eric from our Malaysia team, and he would like to present to you the APx500 version 10, of which one of the main features including the Windows audio. So without further delay, I'll pass it on to Eric. So Eric, over to you.
Hi, thank you, Theo. So good afternoon, everyone, and welcome. My name is Eric Chong, the country manager of TME Malaysia and Indonesia. Today, we are talking about a big change in how we measure audio. In the past, getting highly accurate measurements means using a lot of expensive physical hardware. Today, we are bringing that same high-level testing straight into your PC using Windows WASAPI software. WASAPI stands for Windows Audio Section API. It is a Microsoft low-latency audio interface used to manage, play, and record digital audio streams on Windows. Audio precision is the gold standard for testing all around the world. Companies use our system to test consumer electronics, like headphones and smart speakers, car audio system with many speakers, and advanced research in acoustic labs. Why do customers choose us? It comes down to three main strengths. Ultra-low noise floor. We have the lowest noise level in the industry, so you can trust your data. Easy automation. Our software connects easily with tools like Python, MATLAB, and LabVIEW. Global consistency. A test set up in one country will give the same results in another country, making teamwork easy. To understand why this matters, let's look at how testing has changed. In the old days, audio testing was all about physical cables and analog signals. The setups need big, heavy equipment and a lot of wires. Today, things are very different. Cables are being replaced by digital connections like USB and Bluetooth. However, testing inside a computer brings new problems. Engineers often struggle with driver conflicts, timing delays, and Windows software changing the sound before it can be measured. And this is why we created the new native WASAPI integration in the APx500 version 10. By supporting Windows WASAPI directly, we make testing digital devices much simpler. This software gives you three big benefits. Direct connection. It talks directly to the hardware driver for perfectly cleaned, unedited audio, up to 16 channels. It easily handles multi-speaker setup and microphone arrays. Test anywhere. You can generate and analyze signals directly on your PC without needing to connect a physical AP hardware unit. Let's look at the technical side of why WASAPI is so useful for quality testing. First, it uses kernel bypass. This means the audio skips the normal Windows volume and effect layer, keeping the signal completely pure. Second, it supports asymmetric sampling rates. This lets you play audio at one sample rate and record it at another rate at the same time. Finally, exclusive mode locks the audio device to your test. This stops standard computer sounds like email or chat notification from ruining your measurements. When you compare the old way to the new way, the time savings are huge. The traditional way takes a lot of time. Engineers spend hours fixing driver problems and trying to get different hardware pieces to talk to each other. The new AP version 10 workflow is fully digital and runs right on your computer. You get a clean signal using native WASAPI drivers. You don't need external converters, and you can run fast, automated tests directly from your laptop. This software works perfectly with modern audio connections like USB, Dante, A2B, and others. Because it supports so many systems, you can use it to test conference room setup, car audio networks, or everyday communication devices. Now, let's leave the slide behind and switch over to the software for live demonstration. And this is the setup of my demonstration today. Before we begin, it's important to note that the headset earphones will serve as our device under test for this demonstration. Throughout the measurement process, we will use APx to evaluate its acoustic performance and verify that it meets our test requirement. To begin, we will configure the signal path for our measurement system. For the output device, we will select Windows Audio and choose the headset earphone device. We will use a format of 2 channels, 48 kHz sample rate, and 60-bit resolution. Next, we will open the output settings window. To ensure Windows does not modify the signal level, both output channels are set to exactly 0 dB. And this guarantees that the signal remains unchanged as it passes through the operating system. Okay, since only one channel is required for this demonstration, we will use channel 1 or front left and then close the setting window. On the main panel, notice that the scaling mode is set to analog, and this allows APx500 to display measurement using a real-world voltage value rather than digital full-scale value. Next, we will configure the input path. We will select the Windows Audio as the input interface and choose the Behringer USB audio interface as the recording device. As before, we will use a format of 48 kHz and 16-bit resolution. Now let's configure the measurement input. To ensure Windows does not modify the signal level, input channel are set to exactly 0 dB. We will change the measurement mode from auto to acoustic, and this to tell APx that we are using a measurement microphone, allowing the results to be displayed directly in dBSPL. The next step is microphone calibration. We will use a standard acoustic calibrator with a reference level of 94 dB SPL at 1 kHz. Once the calibration is complete, the RMS level meter will reach approximately 94 dB SPL, and confirming that the microphone sensitivity has been calibrated correctly. To improve measurement quality, we will enable two filters. A high-pass filter helps reduce the low-frequency environmental noise, while a low-pass filter at 24 kHz removes unwanted high-frequency content. Before running any measurements, we'll verify that all the connections are working properly. We are using the verify connection function. We will generate one VRMS sine wave at 1 kHz on channel 1. As soon as the signal is enabled, the input meters respond immediately, confirming that the audio path, microphone, and hardware connection are functioning correctly. With the signal path configured and verified, we are ready to create our measurement. Now that the hardware setup is complete, let's create an acoustic response measurement. I will right-click in the navigator, select Add Measurement, and choose Acoustic Response. AP will automatically create a standard logarithmic chirp sweep covering the full audio range from 20 Hz to 20 kHz. We will keep the default test parameter, a lot chirp sweep, a level of 1 VRMS, and sweep duration of 350 milliseconds. And because the sweep takes only 350 milliseconds to complete, it's extremely efficient and well suited for high volume production environments where test speed is critical. We also ensure that this measurement is included in the automation sequences. Next, we will add the RMS level measurement. To keep the result, we will remove any unnecessary unchecked results from the acoustic response measurement configuration. With the step out complete, we can start measurement by clicking the start button. The system immediately performs the sweep and display the measured frequency response. While the raw data is accurate, it can be difficult to interpret due to small variation caused by the refraction and measurement noise. To make the response easy to evaluate, we will apply 1 and 3rd octave smoothing. And this is a common practice in headphone and loudspeaker testing because it produces a cleaner frequency response curve that more closely represents perceived audio performance. Now let's convert this measurement into the automatic pass and fail test. Using the draw limits tool, we will create upper and lower limit line that define the acceptable performance range for the product under test. To simplify operation on the production floor, we will add an operator prompt at the beginning of the sequence. We name it frequency response test and include clear setup instruction for the operator. And this helps ensure that every unit is positioned consistently before testing begins. Next, we will review the measurement sequence setting. Within the sequence's properties, we enable pass and fail indicators and configure the software to automatically generate a test report. Now, let's run the complete sequence from start to finish. Notice how APx500 manages the entire workflow automatically. It displays operator instructions, performs the acoustic sweep, calculates the frequency response, apply the smoothing, checks the result against the defined limits, and generate the outcome. The test was completed successfully with a clear pass result. The blue measurement trace remains comfortably within the red limit boundaries, confirming that the device meets the required specification. In less than 8 minutes, we have created a complete acoustic production test workflow using the APx500. As you saw, software gives us speed and flexibility. However, when you need an obsolete lowest noise floor and reference grade metrology, AP hardware remains the best choice. WASAPI is designed to complement hardware, not replace it. To close today, I want to share one important note. WASAPI performance depends on the quality of your computer's audio hardware and drivers. For the highest accuracy and reference grade testing, physical audio precision hardware is still the industry standard. APx500 WASAPI software is made to help and expand your testing options, but physical hardware is still best when ultimate precision is needed. Thank you very much for your time. If you want to try the AP500 version 10 measurement software, please contact us.
Hi,
Thank you.
thank you, Eric. Thank you for the interesting introduction to the Windows Audio. Yeah, so next we have our last part of this webinar, and which is the Q&A session. So if there's anyone that you have some question, please feel free to key it into the chat box, and we'll try to answer all the questions. So at the meantime, may I invite all the speakers to turn on your camera to say hello, as I notice this. Eric, hi, Sean, hi, Sean, Gary,
Hey.
Eric, hi. So thanks you guys for the effort in contributing to this webinar. Yeah. So is there any question from the ground? Come on. So we'll remain here for a few minutes to see if there's any question. Yeah. So basically, this webinar is the idea is to give a quick awareness on the latest technology for audio testing. So hope it is interesting for you. Just to summarize a little bit, the seminar is this webinar is basically to highlight a few topics on the updates on Bluetooth 5 and also PSIO, and of course the latest window audio feature that's incorporated into the Microsoft Windows.
I just enable the microphones for the attendees as well. So whoever have a questions, you can turn on the microphones.
Yeah, so perhaps if someone would like to have your question to the microphone, please feel free to speak up.
But if you have any question after the seminar, you still can drop an email to us, and we are happy to answer all the questions that you have. Yeah.
Or perhaps you have some question that's not related to this topic, maybe something that's more towards the analog side. We'll be glad to answer those questions if you have it as well, like for speaker testing.
So far, no question.
Okay.
Not maybe Eric, you want to flash the QR code? Yeah. So.
Yep.
Yeah, so lastly, we will appreciate if you can provide some feedback if there's any area that we can improve for our future webinar. Yeah, so please feel free to scan the QR code and give us your honest feedback. And thank you very much.
Okay. Thank you everyone for joining us today, and wish you guys have a nice week ahead.
Yeah, so if you'd like to find more details about our company, you feel free to visit our company website at www.tmesystems.net.nt. Yeah. Or you can reach out to us via email. Yeah. So we can answer your question in more detail if you wish to have more detailed information about today's topic. Yeah.
Okay.
Otherwise, if there's no question, then we will not delay further this session, and we will stop this session right now. So, and we would like to thank you very much for attending this webinar, and I wish you all have a good day.
Thank you.
Bye.
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 Thank you.
Bye.
Just one
Thank you.
question.
Oh, yes, please.
Yes.
Yeah, Linus.
Sorry, coming in late today.
Yeah,
Is there
be
any
late.
possibility you can see some slides or something that you can share with us from the seminar?
Yeah, sure. Linus, I will share with you. Don't worry.
Yeah.
Okay.
Sorry, I was involved in another meeting. I couldn't make it, but
Okay.
seems to be quite interesting. Hopefully, I just can go through your slide.
Okay, Ken, no problem.
Right. Thank you very
Yep.
much.
Thank you.
Yep.
Yeah.
Thank you, Linus.
Okay. Yeah. Bye-bye.
Thank
Bye.
you.
Thank you. Bye-bye. Have a good day.
Bye.
Bye-bye.
You too.